Hello guys, I'm here to discuss about straight lines. What is a straight line? The one that is appearing on the graph, right? A general form of a straight line can be written as ax plus by plus c is equals to 0, right? As I change the value in a, the y-intercept is being constant, which means the b refers to as y-intercept and the x, right? A value. While I change the b value, the x-intercept is constant, which means a-intercept a value will change the intercept of the x-axis, right? And this n value indicates the distance from the origin. You see, as I change the a value, the distance is being changed. Nothing fun, right? But let's move on to the next line. The slope intercept form. Y is equals to mx plus c. A straight line can also be written as y is equals to mx plus c. And where m indicates the slope, right? Well, let's see how this thing changes. This c, right? Here c in y is equals to mx plus c. The c value indicates the distance from the origin to the straight line on to the y-intercept, right? Distance from the origin to the y-intercepts. So look here. Here I took the c value as 100 and you see the y-intercept is also 100. C indicates the y-intercept, right? Look carefully. This is the distance, and as I change the c value, the line is moving up and down. And as I change the slope, the line is rotating, right? Similarly, not just only let's see, I will take from the slope by minus 100 to plus 100. See, nothing changes. Like the slope increases, the line becomes much more steeper, right? See, let's see what happens if the slope is equals to 2. What does it mean by when the slope is 2 is the for every unit increase in the x-axis, 2 units on the y-axis will be increased. You see, you observe here. For every, look at the blocks carefully. For every increase in the x-axis by 1 unit, the y-axis is increasing by 2 units. 1 is to 2 ratio. Like then let's take the value of the slope be 10. Look at here, just count here to here, like for every increase in the 1 unit there will be 1 2 3 4 5 6 7 8 9 and 10 units. For every unit increase in x-axis, the unit is increasing by y-axis, right? The 10 units is being increased. That's what slope means. And let's see what does it mean by negative slope. It is decreasing. Negative slope refers to as decreasing. To be more precise, I will just take from minus 5 to 5. See, look at how the graph behaves as I change the value slowly. Let me take the slope, which means negative slope, and the slope indicates the slope number, right? The number indicates the number of units increase in the x-axis with respect increase in the y-axis with respect to x-axis, and the negative slope indicates whether the line is increasing or decreasing. This can be expressed by negative slope, right? The sign of the slope. See here, when the sign is negative, the slope, the line is moving downwards. As the values in x-axis increases, the line is decreasing. You can observe it, right? See the slope. In positive, if the slope is positive, if the increase in the x-axis, the y-axis also increases. That's what the slope of the line means. You can understand it, right? Well then, let's convert this equation y is equals to mx plus c into slope intercept form. Then we can arrive at this equation. X by minus c by m plus y by c is equals to 1. You see, when the c indicates this in y is equals to mx plus c, the c indicated the y-intercept of the line. Same here, the y-intercept is c when we convert it into x by a plus y by b format. See, as the change in slope, look how the intercepts are being changed. The point, okay, the point and the intercepts are being changed with the axes. Look here, the change in m and n. See how beautiful, right? Well then, let's see how this thing works. This is the equation of a line 2x minus y plus 7 is equals to 0. And this is another equation. It's the same equation, which is converted into slope intercept form. Assume the c value will be 7, which will be minus c is equals to positive 7 by m value be 2, because minus a by b, if you substitute, the slope will be 2 plus y by c is minus 7. Right, these two lines coincide, which means these two lines are the same lines. Okay, let's understand how differentiation works. Okay, see, what we are looking at here is a parabola. Ax square plus bx plus c is equals to 0. With a clear understanding about the straight lines, let's move to parabola and different shapes. Look at this curve right here. Ax plus by plus c is equals to 0. Beautiful, right? I can change this graph. Same in this parabola, the c value, right? Ax plus b plus c, ax square plus bx plus c. The c indicates the distance from the x-axis, from the origin to the y-intercept of the parabola. Look at here how the graph is changing. And when we differentiate this equation, ax square plus bx plus c, the real magic happens. Let's see, for example, I'm taking a value b like 1. I'm taking a value 1 and b value 1. Let's take 1. What's wrong with 1? C value being minus 5. Look, this is the graph. Well then, let's differentiate it. The differentiation, I took the general form of differentiation. When we differentiate ax square plus bx plus c, we get 2ax plus b. No wonder, right? Look at how this straight line looks. Well, this straight line with respect to this, here the parabola is decreasing, which means the parabola is being decreased, which means the parabola from along up to the this point where it has the minimum value, the value will of the parabola will continues to have a decreasing in slope. See, the straight line has a negative value. The straight line indicates the slope of the parabola at a given point. At a given point, let's see, 15 and minus 5. I will take a line, just see, x is equals to 5 probably. Let's take this line. Okay, at x is equals to 5, look at this thing. This line intersect like 5 comma 11. The value of it is 11, which means at 5 the slope of the curve is 11. Wanna see how it works? Look, for every increase in 1 unit with the tangent, the curve increases by 11 units. That this is what the intercept means. Okay, slope can be represented. The slope of the parabola is a straight line because the parabola from here to here up to the maximum value. Look clearly, observe it. Up to the maximum value, it is the slope of it is decreasing, and then slowly it is the slope is being increased, just like a straight line. Like, let's change the how the parabola looks, right? I want to have negative values. You look at it, just look at this thing, how beautiful. I'm having a negative a value and a b value. The parabola has been reversed, and look at the differentiated equation of the parabola. The straight line, look here, you can see the parabola is being increased up to the maximum height, which means it has a positive slope up to the maximum point. Look at the straight line up to the maximum point. The straight line is being in the positive y, and then after this, the maximum point, the parabola is being decreased. Being decreased means The parabola that has a negative slope. The slope of the parabola is negative. See, and the straight line is in the negative value. Look how beautiful it is. Wanna see, like, when we differentiate, double differentiate, let's double differentiate this. 2ax square plus bx plus c, if we double differentiate it, it will be 2a. You get it? What is 2a? Like, y is equals to 2a. Hmm? Look at this thing, y is equals to 2a, a straight line, right? You see here, the straight line, the when we double differentiate it, the straight line, the value of y is minus 1.4. Look, which minus indicates it has a maximum value. Look at the parabola shape. It has the minimum value of this parabola is like infinity, but the maximum value it is, it cannot go more than, see what is the maximum, 16.175. It cannot go more than 16.175. That's the for this parabola. So let's change the values of it a bit. You see, well, then the parabola, when it becomes this side of the u shape, the, let's look at it, the y value is, when we double differentiate it, the value is 1.4, which means it has a minimum. Look, the parabola has a minimum value. The maximum value of the parabola is infinity, and the minimum value is, see, 1 point. It has a only the minimum value. The maximum of it is infinity. Well, then we don't, we, by double differentiating, we know whether the parabola has a minimum or the maximum value. See, and we can find the minimum or the maximum value just by doing it on paper. This is the parabola, right? And the, look, this parabola with the slope is being decreased continuously, and at one point, like the maximum value or the minimum, the whether the value may be maximum or the minimum, the slope of this will be 0. Look, the slope of this line will be minimum. I'm changing, taking it. See, let's draw a tangent to the graph at here. The point is minus 5.5. Y is equals to minus 26. Y is equals to minus 26. The tangent to the parabola. See, 26.9. 8, 6, 4. See, we are approaching it like the, to the tangent of this parabola. Look, there's a little bit of gap. Let's fill it by 2, 1.9. 19. See, the parabola is becoming, we have a tangent, and this tangent line is 1.8. We close, we cannot find the exact tangent because it's a curve, but the slope of the tangent will be 0. Look at here, because when the curve is changing, there will be a point where it has a negative value. Look at here, where it will be a negative. See, where the slope will be a 0. At the turning point of the curve, the slope will be 0. So by finding this, we can find it. The slope of the line, when the line will be 0, when the slope will be 0, which means the differentiated equation of ax square plus bx plus c is 2ax plus b. If we equate it with 0, look at here how it performs. When we is the 0, it is minus 5.5, right? Equate it with 0 and we get the value of x. The a value is 0.7, which is fixed, and b value is 7.7, which is also fixed. We have to find the value of x, and we should equate the y should be equal to 0, which means when we equate f dash of x is equals to 0, we have to take 2ax plus b is equals to 0, then we get the answer minus 5.5. See, y, let's like a line is equals to minus 5.5. You look at here, right? At x is equals to minus 5.5, the slope is being 0, and the graph has a maximum or maybe minimum. Now, right now it is the minimum value for the graph is here. When you substitute x is equals to minus 5.5, making f of x, f dash of x is equals to 0, you get some value of x. When you substitute the value of x in this equation, y is equals to ax square plus bx plus c, you get the minimum value, maximum value, which is minus 26.175. The graph can look beautiful, right? Next, let's see how it works with a cubic graph. Look at the cube graph, which is looks like this. But there is a point. The we all might have observed, when we differentiate a cubic graph, the answer will be a quadratic graph. The reason for that is the slope of the cubic graph decreases and then increases and then decreases. Look, how many turning points are there? There are two turning points for the slope of a graph. There are two turning points, which means there will be a two tangents with zero. Which equation has two answers at the same time? A quadratic equation has two answers. It's a That's why differentiation of a cubic equation has two solutions. See, let's me change the values a bit so that the graph would look a bit pleasant. Here, same goes with the I value, like the last C value. It indicates the distance from the origin to the x-intercept. You see? Well, then I'm having it. When we differentiate it, y is equals to 3dx square plus 2gx plus h. With a single differentiation, we get this parabola as the differentiator. Look at here. Well, when the equation of it reaches the maximum or the minimum point, the equation of the, let's see at what point it will be a 0, uh, 0.26, right? Y is equals to 0.26. Let's take this thing. X is equals to 0.26. See here, the parabola takes a turn. You look at it clearly. Sorry, it's not a 0.26, 0.2087. 2087. Look, when the line, which means when the differentiated equation, the parabola approaches 0, when the parabola approaches the value 0, it has a curve, like maybe it is a maximum point or a minimum point. Look at here. The same way, let's see it here. Here there is a maximum value for this thing. It is the, like, which means the curve is being changed, which means we can have a tangent here with the slope 0. Okay, with the slope 0, the which means let's find the solution for this parabola at 0. 4.91. Let's change the value to 4.91. 4791. 4.791. Look at here. Look at the straight line here, which means by finding the roots for this parabola, we can find where the parabola have the curves. Same goes for the parabola and as a cubic equation. But the real magic happens when we double differentiate this thing. Look at here. Let me double differentiate it. We get a 3d plus 2g. I'm hiding this straight line here. Look at this. The red line indicates the original equation. The blue curve indicates the differentiated equation, and the green line indicates the double differentiation. Okay, let me take a break. Resume. As you can see, the equation, the differentiated equation, and the double differentiated equation. You see, like, whether the what does the double differentiated equation would tell us? If the graph is being, if the graph has a minimum value or a maximum value. Let's see. With the current values of d being minus 0.2, g 1.5, h minus 0.6, and I minus 0.7, the double differentiated one will have a 1.8 value, which means the graph you will have the 1.8 dx, sorry, a small mistake here, dx. See, hmm, this is the graph. The original equation differentiated and double differentiated is a straight line. Look, instead of coming at a point like when we double differentiate it, like a parabola, when we differentiate a cubic equation, double differentiate a cubic equation, we get a straight line, which means whether look at here from up to 0, look, up to this point, it will have a minimum point. Look, the straight line where it intersects the x-axis, the double differentiated, it intersects the x-axis at 2.5, which means up to 2.5 the graph will have a minimum value. Look, the 2.5, the graph is being on the upside, which means positive value. The double differentiated has positive value up to 0.5, which means let's draw a straight line at 0.5 for a clear understanding. Let me get it here. See, the double differentiated for a clear understanding, I will mark up a line here. When the double differentiated indicates 0.525, x is equals to 0.2.5. Get it? And x is equals to up to x is equals to 0.5, the current graph will have a minimum value, which means it is positive. The green line is in the positive range up to 0. Up to 2.5. The graph will the green the up to 2.5, the curve will have a minimum value, which means as you can see in the green, up to 0.5, up to 2.5, it has a minimum value. After 2.5, the slope of the green line is negative, which means it has a maximum value. Look here, it has a maximum value after this purple line. The right side of the purple line has a negative green line, which means only has a maximum point for the red line. Similarly, on the left side of the purple line, it has a positive green line, which indicates that the red line has a minimum. As you can see, the red line only has a minimum. Okay. Similarly, let's jump on to how this line works. How a 4 with power 4, I don't know what we call it, with the power 4, we have the power 4 equation will have a 4 roots. Look at here, 1 2 3 and 4 roots. This is how the power 4 equation looks, and we can change the j value, k value according to our wishes. Look at here, I can change this thing up and down, can play with this. Hmm? Look at here, this, let's assume this is the graph we take, and it can have a j value being negative or it can have a j value being positive. The positive j value, the graph will be look like this upside down graph, just like a parabola. With the positive j value, it will look like a upside parabola, and it will have a maximum point. Look at here, it will, if the j value is positive, it will have a maximum point. If the j value is being negative, it will have a lower point. It has a, like, the mean maximum point, and if the j value is positive, it has a minimum point. Just look at here how it works. Stretching, let's see the graph being like this. Zoom into the graph, then differentiate the graph. This blue line, black line, sorry, this black line is the differentiation of this thing, of the blue line or purple line. Look at here, this has as a minimum peak at here. Let's look at the peaks. Peak at here, which means the black line has a zero at here, and same goes here. It has a peak here, and the black line, wherever the black line hits zero, the equation, the blue line has a peak there. Look, for a for the y power 4 equation, there will be three peaks, which means the differentiation is a cubic solution. It hits zero three times. Look, the black line hits zero three times, and it has a one, two, and three, three like three at here on top of here, three peak points, and the black line hits three times. Okay, look, fascinating, right? As you can see, it has an increasing. The up to the purple line increases, which means the black line is in the positive y-axis on positive y, and then after hitting here, this point after hitting here, the purple line is decreasing. It has a negative slope up to certain, if this point, look at here, up to this point it has a negative slope, and then it starts increasing. Look, it starts increasing up to this point. Up to this point it starts increasing, and then it falls. Look at the graph, same. When it is positive zero, when the black line is above the zero, the graph is increasing. When the black line is below the x-axis, the purple line is decreasing. That's how this works. When let me double differentiate this thing. Okay, seems a bit gymnasium, but look at this. The double differentiation line is the green line, which is a parabola, which means it has a positive one. Look, with parabola, which is referring to as, it has a negative value, which means it has a minimum up to 2 point. It has a the parabola up to, it has a negative. Look at here, minus 0.85. Just draw a line. Y is equals to minus 0.85. X is equals to, so want another color instead of black. X has a red line. Look at here, until this the double differentiated line green, where it hits the zero. Look, it hits zero at 0.085. Sorry. Look at here, up to, look at the red line. Just I'm hiding the black line just to be some bit sure. And the green line. See, up to the red line here, it has a maximum point. Look, as you can see, let's make the black line appear. Okay, the green line, look at the green line, which means the green line hits zero at here, and up to it hits zero, the green line is in the negative thing. Negative, which means it has a maximum up to this point. Up to it has a maximum value. Look at the peak, it has a maximum value. Then where the green line hits zero the second time, look at here, where the green line hits zero. Hey, no, the green line is being after here, it is in the positive direction, which means up to here, this point, it is in the positive up till here point, this point, where 1.6, x is equals to 1.6. 1.6, look at here, up to x is equals to 1.6, the green, no, 1.96, up to 1.96, the green line is stayed in the positive region, which means it has a minimum value. Look here, it has a minimum value, right down there, and up to here it has a minimum value up to the what, 1.96 value. And then see, It has a maximum and a minimum values. That's how the differentiation works. And then let's do a spicy problem mixing both these things. Notes, calc. Look, let's look at the question. A straight line with negative slope passes through the point 8 comma 2 and cuts the positive coordinate axes at P and Q. Find the minimum value of OP, like the x-intercept and the y-intercept, where we have to find at what slope the sum of the x-intercept and y-intercept will be minimum, and the slope must be ranging at the minus. You see, let me show you a bit of small Jagannath magic. I'm taking this y is equals to mx plus c point. Let me take a point right here. C value is can be changed right here. Let's take a point, some random point. Let me take some random point. I want it in x. Let's say not this thing. I will change the equation. Y minus, we want now, I want the line to be passed through a particular point, y minus y1, like let's say y minus k is equals to m into x minus l, or let's have sliders for this thing, and I will take the k value be 8 point. Let's zoom this thing. Hmm? The k value, let's have a k value which means the y-intercept, and k value as 6 and L value as 2. Let's have it as 2, which means it passes through the point 6 comma 2, 2 comma 6, 2 comma 6, 2. Let's label, okay, which means this line and m, let me get this m slider down here. Look here, as the slope changes, the line falls down up and down, okay, which means if it has a negative slope, it cuts the positive x and y intercepts. If it has a positive slope, this line cuts to the positive y and the negative x-axis. Similarly, if I change the coordinate for this point, right, hey, y is this can be clear. Okay, let's change the coordinate from the quadrant. Let's change it to quadrant 4. Look at here. When the line is changed into quadrant 4 with the negative slope, with the slope of positive 1.4, it hits the x-axis at a positive x-axis and negative y-intercept. Positive x-intercept and a negative y-intercept. Look how this thing works. As I change the x, let's change the coordinate to the second quadrant. Let's move to the second quadrant. And the second quadrant, let's see how the positive and the negative, how the x and y intercepts are changing. And similarly, let's change the point to the third quadrant, and see how the x-intercept and y-intercept behaves when it has negative slope and a positive slope. Look, okay, I can change the point wherever I want, right? See how it works. We can play with this. Mm, let's see we how do we play with this, making these lines invincible. Let's have a point, let's say a b c. A comma B be the point, and let's make this line visible. See, as I change the x and y values here, I'm having looks like a game, right? I can change the x and y values and the quadrant, this thing, the parabola changes as I move this black dot line. Look, x and y is being changed, which means the a and b values are being changed, just like this. Okay, let's get back to the question that we are supposed to solve. Okay, here it is mentioned that it has a 8.2 and a negative slope. Okay, it has an 8.2 and a negative slope. Let's see how do we represent 8.2 is referred to as first quadrant. In first quadrant, when the slope is being negative, it hits the positive x and positive y intercepts, just like it is mentioned in the question that it hits the positive x and y intercepts. We have to find the minimum value when it is that when we add the sum of the intercepts. Let's look at that question. I'm hiding all the lines just to make it visible. There is this point 8 comma 2. Look here. Hmm? We have to write the equation y minus y1 is equals to m into x minus x1. The equation of this line. Look, and we can, which means this equation, this line passes through the point 8 comma 2 and can change its slope. As I move that slope, as I change the slope, look how it is being changed. Hmm? See how beautiful, right? How the slope is changing. Well then, let's do some math. Here they asked about intercepts. When we write y minus y1 is equals to m into x minus x1, we can get equation. When we convert it into slope intercept format, we get this thing. The x-intercept will be 8m minus 2 by m and the y-intercept will be minus 8m plus 2. When we add these two things together, we get 8m minus 2 by m minus 8m minus 2, right? F of m is equals to, well then, assume that f of m is y, and the equation, I'm hiding this white line. Let's see, don't have to hide, I guess. Look at here how this thing is changing. Look, this thing has a two curves, which means, look, it is a bit weird. It has a two different curves, right? Let's look at the how this curve works. We have to find it when it has the minimum in the negative values, which means it is mentioned that the slope is negative, which means the x is only minus, which means we have to look at the second and third quadrants. In the second and third quadrants, it has the minimum. We have to find the minimum. The minimum value is 18. By looking at the graph, we can tell that it's 18, but we don't always have graphs in our classroom. So let's just solve it. Hmm? To solve this, we have to differentiate this thing. When we differentiate this line, we get minus 8x square plus 2 by x square. Just I differentiated this line using u by v format. When we differentiate it, we get this black line. Look at here how this black line moves. Okay, I wanna just experiment a bit before differentiating it. Just have it m and m. It will be a straight line. Look at here. And the question is that when the value will be minimum, when the as I change the m value. Look at here, the slopes is being added. It has to be a negative. Let me check. The slopes is being, hey, look, the graph answer will be the line y value is being 43, it slope will be minus 3.5. It's coming lower 29, 28, 27, 1.5, 20. It is 18 at 0.8 and 18.45. At 0.45 it became 18 and it went up again. It went up. Look, as it changed the value of m. See? Hmm. Let's get back to the question. Look, Well, then it is the differentiated equation of these two lines. I'm hiding the y minus 2 line just to be a bit focused. This is the differentiated equation. Look it here. The differentiated. As we can see, this line appears to be a straight line as we move along. What does the form of a straight line? A straight line has a constant slope, which means it looks. Look at this. It has a like not a constant, but almost similar to a same slope. This line has up to here. Look, this curve hits zero here. The differentiated equation hits zero. We have to find the roots for this. The differentiated equation. Okay. How about look how we differentiated it. When we differentiate it, you get the roots. When the value will be 0, at minus 0.5 it has the 0 points, and at minus 0.5 look at the curve, it has a minimum. Similarly, it has a same goes for this line. Look at here. When we this line hits 0 at positive 0.5. At positive 0.5 it has the maximum. For finding it, let's do a bit of double differentiation. We get here, let me see, I did the double differentiation. Double differentiation. Let's do the double differentiation using a differentiation calculator. See, differentiation, go. Let's get the answer. Plus 2, I don't think, okay, let's say x plus 2. Okay, result. Look at these graphs. Here it is already built with graphs. When we differentiate it, we get an equation. Let's get the equation is, we can rewrite this as first differentiation for 4 by minus x cube. Look at it. This differentiated, we can get 4 by x cube when we differentiate it. Calculate or minus 16. Look, let's see how it will look like. Minus 4 by x cube, right? Minus bracket of cube. I don't want this color. It is in the purple line, which is confusing us a bit. Let me get another color. Red. Okay, red. Looks clear, right? Look at the differentiation part. When we double differentiated this, it has a positive up to the in the second and third quadrants up to 0. It has a positive, which means it has a minimum value. Look at here, up to 0 it has a minimum value. Look, the red line, it's up to 0, it's in the positive direction, which means it has a minimum value 18. And the red graph, after 0 it has a negative slope. It is in the downside, it has a negative value, which means it has a maximum. Look how it only has a maximum. Okay, to find where it hits 0, look at here, we have to find the roots for this differentiated equation. Let's find the roots for the differentiated equation. When we find roots for the differentiated equation, we have to f dash of x is equals to 0, and we get right m will be equals to plus or minus 1.5, plus or minus 1.2. Look, I'm hiding these lines. Okay, just look, it will be plus or minus 1.5, just as it is in the mentioned in the graph. Look, at minus 0.5 it intersects at 0, at plus 0.5 it intersects at 0. Fun, right? Let's see. At, to find the actual solution, at 0.5 we know that it has a maximum or minimum value at 0.5. Let's substitute it at 0. Minus 0.5. When we substitute it into 8m minus 2m by minus of 8m minus 2, we get this 2. 12 plus 6 is equals to 18. You understand the calculation part, I guess. It will be 18. As we can see here, the minimum value of this thing is 18 at minus 0.5. See, beautiful, right? Similarly, if we substitute this positive 0.5, we get around, what is the value? The peak here. Positive 0.5. X is equals to 0.5. Hmm, Get here. It has a 2 value, the maximum value of 2. You can check it by substituting it. As x in the place of x value, we have to substitute 2 in f of y. Let's see what we'll get. 8 2s are 16. 16 minus 2, 14 by 2. Answer will be 7 minus of 7. That's this value will become 7, and this value 8 to the 16 minus 2, like 14. 7 minus 14. It's 0.5. I am taking it as 2. 4 minus 2 will be 2. 2 by m. The answer will be 1. 2 by m, the answer 2 by 0.5. 2 by 2.5, the answer will be 4 we get. And then minus of 8 into 1.5. 4 minus 2. The answer will be 2. Minus 4 minus 2. See, 4 minus 2. The answer is equals to 2. At positive 0.5, it will be 2. But the question specifically mentioned it has a negative slope, which means on the negative side, the minimum value it has is 8. Clearly understood? I hope you learnt a lot instead of boring. Let's stop the video now. Bye bye, guys.